In 1976, an aircraft flew from New York to London in 1 hour, 54 minutes, and 56 seconds. To put that into perspective, a Boeing 747 takes about 7 hours. This aircraft wasn't a spaceship, but a machine built on Earth, the SR-71 Blackbird. And the secret behind its success was also the cause of its biggest problem. It leaked fuel like a sieve when on the ground. Hello, welcome to Wingtip Tales, where we explore the wonders and mysteries of aviation. Today we're going to uncover the engineering behind the fastest and highest flying reconnaissance aircraft ever operated. How did Lockheed's engineers solve the extreme challenges of flying at Mach 3.3, where the aircraft's skin temperatures reached up to 300 degrees Celsius? Point 1. The secret mission. Created during the Cold War, the Blackbird was born for a single purpose: to fly over enemy territory so high and so fast that no missile or fighter jet could reach it. And it fulfilled that mission for decades, without ever being shot down. In the 1950s, the CIA needed an invulnerable aircraft. The U-2s were already becoming targets. Engineer Kelly Johnson and his team at Lockheed's Skunk Works were given an extreme challenge: to fly at Mach 3 plus at 85,000 feet. Conventional materials would melt. The solution came from an unexpected place. They secretly purchased titanium from the Soviet Union through third parties, disguising the true buyer.
The most sophisticated aircraft in the U.S. Air Force inventory today. The Blackbird construction is 90% titanium alloy, which required a whole set of new techniques to fabricate. Hot presses to form and size the parts. Machine tools and drills to cut the new alloy.
Point 2. The heat challenge. Extreme speed generated insane heat. The solution? A fuselage made of titanium, a rare metal and extremely difficult to work with. But there was a paradox. On the ground, the fuselage joints were intentionally loose. Only at high speed, as thermal expansion occurred, did they seal perfectly. Titanium is strong, but brittle and extremely difficult to weld. The team discovered that common tools contaminated the metal, forcing them to reinvent metallurgy from the ground up. The greatest paradox? On the ground, the aircraft intentionally leaked fuel. The joints were loose by design. Only in the air, as the fuselage heated to 300 degrees Celsius and expanded by nearly 15 centimeters, did everything seal perfectly. It was a machine built to live in the hell of thin air. Point 3. The special fuel. Conventional fuel would evaporate. Engineers developed JP7, a fuel so stable that it required an explosive igniter to burn inside the engines. And yes, the aircraft leaked fuel on the ground because its tanks were designed to expand in the air. Conventional fuel would evaporate. Engineers developed JP7, a fuel so stable that a lit match would go out if dropped into it. To start the engines, they injected a hypergolic fluid, TEA, that ignited spontaneously on contact. The Pratt Whitney J58 engines were unique hybrids. Below Mach 2, they behaved like conventional turbofans. Above that speed, 6 massive bypass valves opened, redirecting airflow to the afterburners, effectively turning them into true ramjets. Point 4, the perfect shape. Every curve of the Blackbird was designed to reduce radar signature. It was stealth by design. Even today, its shape remains iconic. The cockpit reached external temperatures of up to 120 degrees Celsius. The pilots wore pressurized suits similar to those used by astronauts, connected to a specialized air conditioning system. A single leak meant instant death. For reconnaissance, the aircraft carried ultra-high-resolution cameras. It's said it could read a car's license plate from 26 kilometers above the ground. Its only defense, as one pilot famously said, was to accelerate. No missile ever caught it. In 1989, during its retirement, a Blackbird flew from Los Angeles to Washington, D.C. in just 64 minutes, an unbeatable record. The SR-71 Blackbird was far more than just a fast airplane. It was a masterpiece of extreme engineering, where every problem was met with an innovative and sometimes counterintuitive solution. It was retired not because it became obsolete, but because satellites took over its role. Its legacy of speed and secrecy remains unmatched. If you enjoyed exploring these engineering secrets, leave a like, subscribe to the channel, and hit the notification bell. And in the comments, tell me, which legendary aircraft would you like me to uncover next week?